Alright, today we're looking at a new section, and I'm not going to be taking this from the book, so you have to get all of your information from this lecture, or look it up online too. That's another option. But we're looking at piecewise functions. Now, a piecewise function is a function that can be in pieces. So if we're looking at a function in pieces, a piecewise function, we're going to be looking at a graph that has different sections to it. So we can create functions that behave differently based on our x inputs, our values for x that we put into a function. So in this basic example here, notice that this function has three different pieces to it. 1, 2, and 3. So we have three different sections to it, three different pieces, and each of these, let's say this is 1, this one is 2, and this one is 3. Each section, each piece, 1, 2, and 3, has its own equation to it. And we can find these equations, write out the equations in a specific format, or we can solve for different values given a certain interval. But the idea, when we look at our three different sections here, is that notice they start and stop at specific points, different intervals. So function number 2, it only works from 1 to -3 to, looks like 1.5, positive 1.5. So over this interval for x values, so when x is greater than or equal to -3 but less than or equal to 1.5, this function is valid, it works. We're going to graph it over that specific piece, that specific interval. So the example here is when x is less than 2, so when x is less than 2, we get this function. We're going to graph f of x is equal to x squared. Now when x is exactly 2, if x equals 2, then we're going to graph this function. The function is equal to 6. When x is more than 2 and less than or equal to 6, so if x is greater than 2 but less than or equal to 6, well, the function we're going to get is f of x is equal to 10 minus x. And that is our piecewise function. Now, it's not the actual notation we're going to be using. I'm just explaining the concept. So we have three different intervals, three different pieces or sections to this graph. This one right here, that corresponds to this one. So whenever I pick a number on my x-axis, that is less than 2, well, the graph I'm going to use, the function I'm going to use, is this one. That's my first section. Second, if I pick a number on the x-axis and it is exactly 2, well, the function I'm going to use is just 6. F of x equals 6. So that would give me that point right there. And my third condition is that if I pick a number on my x-axis and it's between 2 and 6, is greater than 2 but less than 6, well, then the function I'm going to use is this one right here, 10 minus x. So I have three different conditions that are being used, and each gives a different function on my graph, or a different piece, i.e. piecewise function. Now the way that we can actually write this, if I take, let's say I just gave you the graph like this, and I said, well, what's the actual piecewise function? We're not going to do it like I did here, where I write each individually and then do the conditions in 1, 2, and 3. We're not going to do that. The actual notation that we'll use is going to be looking something like this. We're going to say f of x, the function evaluated at x, is going to equal, I'm going to use a big bracket here, just like that, and I'm going to say, let's start with this function. I'm going to say that function is x squared, and that function works, so f of x if x is less than 2. So this is my first condition. I'm going to say I'm only going to use this function, or this function, if I pick a number that's less than 2. And that will give me this graph here. Or this graph gives me this function, either way. Now notice from the graph, I have an open circle, where open doesn't include, so it's just going to be less than greater, or greater than. Remember, a closed circle, that's when you use greater than and equal to, or less than or equal to. So I've taken care of my first portion, my first piece of the graph. Now let's go to my second one, which is that guy right there. So for that, I'm just going to say, well, when x is equal to 1, 2, that gives me 6. So my function is just 6 when, or if, x equals 2. Now let's go into the last portion of my graph, which is this right here. Well, that function is going to be the 10 minus x. So that function works, it's used if your x value is greater than 2, not equal to because open circle. It's greater than 2, but less than or equal to because it's closed. 6. 2, 3, 4, 5, 6. And so this would be my piecewise function. That would be my answer. Now conversely, if I gave you this, you could graph it like this as well, which we'll do in this one. So first question states, we have the function h of x, and we have the piecewise function of 2. If x is less than 1, less than or equal to 1, we're going to use x if x is greater than 1. So to graph this, let me use a different, let's use this one. So we have our x and y axis, and we'll be graphing these two functions here. So h of x is equal to 2 if, what was it, x is less than or equal to 1. We're going to be graphing x if x is greater than 1. So let's start with this function here. So I'm just going to be graphing 2 whenever x is less than 1. So here is 1. So I'm going to go up to 2. 1, 2. I'm just going to draw a horizontal line, a closed dot right here, and I'm saying x is less than or equal to 1. So less than, this is the less than side. So I'm just going to draw a horizontal line going through 2. Just like that, and it just keeps going. So arrow. So that's my function x, h of x equals 2. So I've taken care of my first graph. Now let's jump down to my second graph, which is x, but I'm only going to graph it if x is greater than 1. So typically, the function h of x equals x, that's just going to look like this. Using slope-intercept form, my slope is 1, my y-intercept is 0. So I start here, rise over run, 1 over 1. So just go up 1 over 1, up 1 over 1. So I typically would get something that looks like this. But my condition is saying that I'm only going to use this function when x is greater than 1. So I go to where x is 1. I just jump up to the graph right here. So I'm going to only use the portion that's greater than 1, which is only this side. And so all I'm going to do is cut off the rest of this portion. So I cut everything else off. I'm left with, I use an open circle because it's just greater than. I'm left with that. And that is my piecewise function. Now the second question is, what is h of negative 1? So for this one, how we solve it is, so 1b, I have h of negative 1, and I have 2, let me write this again, 2 if x is less than or equal to 1, x if x is greater than 1. Yeah. So what I'm evaluating is negative 1. Well, this negative 1, which of these conditions does it meet? What this means is negative 1, that's my x value. I'm saying x is equal to negative 1. Well, does that fall into this equation? Or does it fall into this equation? Well, since x is negative 1, that's what I'm assuming, and negative 1 is less than or equal to 1, that satisfies that condition, I'd be using this equation. So my solution here is h of negative 1 is actually equal to 2. And we look back at our graph. If I go to negative 1, where does that, negative 1, where does that, if I go up to the graph and look for the intersection, where does it intersect the graph? Well, it intersects when at 2, y equals 2. So that's my answer. Well, let's look at our next question. What is h of 1? H of 1. So what would h of 1 be, evaluating when x is equal to 1? Which of these conditions does it meet? Well, since x is 1, x is equal to 1, satisfies x as being less than or equal to 1. So I'd be using this equation function. So my solution here would be h of 1 equals 2. Now our last one is h of 4, so 1d, h of 4. Well, that is going to be, I'll look at x is equal to 4. Which of these conditions does it meet? Well, 4 is greater than 1, so I'll be using this equation. So my answer here would just be h of 4 equals 4. So I just plug it into the equation. All right, let's do another example. Example 2. So this is our piecewise function here. Let's go ahead and graph it. So I have x squared if x is greater than 2, and x minus 1 if x is less than or equal to 2. So let's start with, so x squared, x is greater than 2, and then x minus 1 if x is less than or equal to 2. So let's start with our first function, x squared. Now typically I would have, using our function x squared, if we looked at xy table, 0, 1, 2, negative 1, negative 2. So I square negative 2, that gives me 4. Square negative 1, that gives me 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So typically I would be using, let's do a few more. 3, 4. 3 squared is 9. 4 squared is 16. So typically, if I was graphing normally, I graph all those points. But since I'm only using the values when x is greater than 2, I'm only going to be using everything greater than 2. So I'll start with this value here. I'm going to go 2, 1, 2, 3, 4. But I'm going to use an open circle because it does not include 2. And do 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9, and it just keeps going up and up. Just like that. Now, again, typically this would come down like this. And start going back up like here. But since I'm basically chopping off this whole graph, getting rid of this whole portion here, and only keeping that because of my condition stated here. Now let's go ahead and graph my second function, x is greater than 2, which is this one, x minus 1, but I'm only going to graph it when x is less than or equal to 2. So what would be you could always graph using a table if you wanted to. Might be easier to think about it that way. So let's just start with negative 2, negative 1, 0, 1, 2, 3. Well, I'm doing x minus 1, so that's what my y value is equal to. So start at 3. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. 0 gives me negative 1. Negative 1 gives me negative 2. Negative 2 gives me negative 3. So typically I graph all those points, but since I'm only taking the values that are less than or equal to 2, my x values that are less than or equal to 2, I'm only going to be using these coordinates. So when I graph those, I get 2, negative 3, or I'm sorry, 2, 1, so right here. And I'm going to use a closed circle because it includes 2. X is less than or equal to 2. 1, 0, 0, negative 1, 1, negative 2, or negative 1, negative 2, and negative 2, negative 3. And it just keeps going that way. Typically I go all the way up here, but again, I'm chopping it off at 2, so I only use that portion of the graph. So that is what the function would look like there. Now let's go ahead and evaluate when f of 4. So what happens when x is equal to 4? What would be my evaluation of the function? What's my y output? Well, I could look at my graph here. So if I go to 1, 2, 3, x is equal to 4 right here, I go up to the graph and look for the corresponding y output. That's one way to do it. Or I could just say, which condition does it satisfy? Is 4 greater than 2, or is it less than or equal to 2? Well, obviously 4 is greater than 2, so I'll be using this function, so I square 4, which gives me 16. That's my answer. What about if I'm saying x is equal to 2? What's the function when x is equal to 2? Well, is x greater than 2, or is it less than or equal to 2? Well, it's less than or equal to 2, so I'll be using this function. So all I'm going to do is take 2 minus 1, which gives me 1. That's my answer. Last one is f of 0. Well, obviously that's going to fall in this category, so I'll be using this function, so this would give me negative 1. So that is piecewise functions. That's how you graph them. You can also take your graph, get the corresponding functions from the graph, and you can also evaluate different x values in a piecewise function. You just have to look at which criteria does it satisfy. And then you plug it into that corresponding function to get your y value. Alright, if you guys have any questions, feel free to email me. But other than that, I'll see you around.